Merry Christmas, and I like to talk about how the options are priced as far as the theoretical models are concerned. So I'm going to take a look at an example for Tesla here, and as you can see, it has an option for January the 20th expiring for 125. It's a call option, and it is priced as $10.35 for one option. So you can see the price that was last traded was 10.35. So you would notice that you usually have a way to see it in your screen. The three particular elements that are important for option pricing. And there are actually, and these are called the geeks. And the first one is called the delta. Then it's called the vega and theta. So we have the three geeks and there are some values. So let me explain to you what these geeks means. So delta is the first geek, and it's basically defined as a theoretical change in option price for a $1 change in the price of the underlying security. So the easiest way to understand is, let's say the price of Tesla goes up by $1, then the price of the option will go up by 52 cents here, 52 cents. And if it goes up by $10, then the price of the option would go up by $5.24. So you can see that in this case, approximately $1 increase in the price of Tesla shares will cause about 52 cents increase in the price of that particular option. And that's how the delta is priced. So delta, this is how you can understand the delta. Then the second geek that is important is for an option is called theta, and which is basically a time decay, because as you know, for this particular case or any other options, they have a date on which they expire. So the example I was showing you, the option would expire on January the 28th. So theta basically measures the change in an option's theoretical price relative to 1 day of time. So what happens in 1 day of time? So let's say 1 day passes, then the price of theta is negative 19 cents, you can see. So the price of the option would actually decrease by 19 cents as 1 day passes. Similarly, if 10 days pass by, the option's price would actually decrease by $1.97. So as you can see, essentially the price of option decays over time, and when it is the time for expiration, option cannot be traded after that. So basically you have to really either sell the option before that time or actually exercise that option, or it might actually go worthless, but those are the only things. So that's how you can understand the theta. So if for some particular option the theta is high, then you can see it is going to decay very rapidly. So that's how you can understand the theta in the option pricing models. Then the last one is vega, and vega actually stands for volatility, and essentially the meaning here is vega represent the change in an option's theoretical price for a 1% move in the volatility of the underlying security. So let's say that Tesla volatility increased by 1%, and since its vega is 0.1382, the price of Tesla would actually increase, the option price would increase by 13 cents approximately. You can see if it is increases the volatility by 1%, it will increase by 13 or 14 cents approximately. Similarly, if the volatility of Tesla shares increase by 10%, then the price of the option would actually increase by $1.38. So as you can see, these are the three big geeks that have major ramifications for the pricing of options. To recap, delta has to do with the price movements in the stock, theta has to do with the time decay, and vega has to do with the volatility. Thank you for watching this short screencast, and again, Merry Christmas. And if you have any questions, feel free to post it on YouTube, and I will try to help you out. Thank you. Bye.